Okay, in this video, we'll continue doing type 2 error problems, but this time we'll be talking about proportions, which always use the z-distribution, and distributions for which we do not know the population SD, meaning we need a t-distribution. Once again, the questions will all have a what-if statement, and that is our clue that it's a type 2 error question. And since this problem is about proportions, we already know that we're going to have a z-distribution. We always begin these questions by finding the critical value. Here is the distribution under the null hypothesis that p equals 0.6. This is a one-tailed right-tail hypothesis, so there is a critical value k in the right tail. Since the level is given as 10%, that means that the area beyond the critical value is equal to 0.1. For the z-distribution, we know that this happens when z is equal to 1.282. Create z by subtracting p and dividing by the SD, but it's not the same z formula as in the last video, it's the formula for proportions. So remember that p shows up twice in the SD too. So when we assume from the null hypothesis that p is equal to 0.6, it shows up here, here, and 1 minus p here in the formula. So set the z formula equal to 1.282 and solve for k. And we get the critical value is equal to 0.6662. Remember that this means that we will reject if the sample proportion p hat is greater than the critical value, and we will not reject if p hat is less than the critical value. And this is what we're interested in because type 2 error is all about not rejecting. So we're going to find the probability of not rejecting, but now we're going to assume that p is equal to 0.65. This was the number given in the what-if statement in the question. Now I create z by subtracting by p and dividing by the SD, but just remember that p shows up in the SD as well. We get z less than 0.32, and checking the z table, we see that this probability is equal to 0.6255. So there's a fairly large probability of type 2 error if the population proportion is actually 0.65. Okay, now we're back to a hypothesis about oranges. Here is the what-if statement that all type 2 error problems have. This question is about means, but no population SD is given, only the sample SD is given. So this means that we'll be using a t-distribution. Specifically, since the sample size is 28, we'll be using the t-distribution with 27 degrees of freedom. Here is what the distribution looks like, assuming under the null hypothesis that the mean is equal to 200. We begin, as always, by finding the critical values. This is a two-tailed hypothesis, so there's an upper and lower critical value. Since the level is given as 5% in the question, the area in each tail must be 0.025. So we must check the t-table to find the t-values that give us this area. With 27 degrees of freedom, the t-values are plus and minus 2.052. Remember that the t formula is almost exactly the same as the z formula. The only difference is that we have the sample SD in place of the population SD. So we'll get the lower critical value by setting the formula equal to negative 2.052, and we get the upper critical value by setting it formula equal to positive 2.052. Solving both equations, we get the two critical values, 198.643 and 201.357. And we would reject if the sample mean is too large or too small, but we would not reject if the sample mean is between these numbers. And that is what I need for type 2 error. Now we assume that the mean is the number from the what if statement in the question. We create t by subtracting the new mean and dividing by the SD. Once again, this creates t with 27 degrees of freedom. The negative 5.807 is way off the t-table, so ignore it. The area out there is essentially 0. And by a stunning coincidence, negative 1.703 shows up exactly in the t-table. So the area in the left tail is 0.05. So that is the probability of type 2 error. Okay, here is another question about proportions. That means we have the z distribution, and here is the what if statement that all type 2 error questions have. And we are given that the probability of type 2 error equals 0.05, and we have to solve for the sample size. So get ready for another long one. Here is what the distribution looks like, assuming under the null hypothesis that p equals 0.2. This is a one-tailed left-tail hypothesis, so there is a critical value k somewhere over in the left tail. Since the level is given as 1%, the area in the left tail is equal to 0.01. For the z distribution, we know that this happens when z is equal to negative 2.326. We create z by subtracting by p and dividing by the SD. Remember that p shows up in the SD2. And we're going to set this equal to negative 2.362. Solving for k, we get this expression. Once again, I'm going to leave this aside for now and use it later. Now I have to think about the definition of rejection. And since this is a left-tailed hypothesis, we would only reject if the simple proportion, p hat, is less than k. Sorry, this should say p hat. And we would not reject if p hat is greater than k. And we're going to do this under the assumption that p is equal to 0.16. Since that was the number given in the what if statement in the question. So we create z by subtracting by p and dividing by the SD. Remember that p shows up in the denominator too. The problem tells us that this probability is equal to 0.05. Well, if z is greater than some number and the probability is 0.05, then the area in the right tail must be 0.05. That means that z is equal to positive 1.645. Set the formula here equal to 1.645, and we get this expression. Once again, we now have two equations with two variables, k and n. Now I'm going to use the equation from the previous slide. You might want to rewind and take a look at it and substitute it into this equation. This part here is what I substituted in for k. And we can now solve for n. It's almost identical to the last video, so you should know how to do it. You should get that n is equal to 1,469.7, round up to 1,470. Remember, all type 2 error questions follow the same basic pattern. You find the critical values using the null hypothesis, and then you find the probability of not rejecting using the number from the what if statement given in the question. Okay, you now have 3 questions to try on your own. Good luck with that, and I'll see you in class.